Hello and welcome back to module number 3. We are going to talk about two subjects today, and as we're moving along, we also going to focus on the R and how the R treat this type of analysis. So today we are going to move away from what we have covered so far with regard to descriptive statistics. And the idea in descriptive statistics, usually it's involved around one variable at a time. We measure the mean, we measure the standard deviation, but we are examining one variable at a time. Now, the issue comes into interest is the idea of relationship between two variables, and how can one variable can predict or affect another variable. Example, the SAT scores. Is that a good indicator to your performance in university? Or when you are eating vegetable, does it make you fit and healthy person? I would vote yes, but I did not have anything to rely on. So all those questions is about relationship that we are going to examine and to try to understand. As you know, I am a very visual person. So one of the things that we often do in order for us to illustrate and visualize the idea of the two relationship is scatter plot. And we use it to graph the relationship or the value of two variables in a plot where we have two axes. And the idea here is that one affect the other. Example, age and fat in the body. As I can tell you from my own experience, I cannot predict anything. As I get older, I'm heavier and again gain a lot of weight. So again, what is the relationship between age and fitness is part of this idea of what we are trying to do with bivariate. Bivariate is the examination of two variables and idea of what it will consist. So again, as this data indicate, as we get older, we become fatter and in this direct or straight relationship with that. So another example is advertising and sales, and this is ongoing debate. Are we going to invest in advertising in order for us to have better sales? And again, usually they have a formula for that, but a straightforward approach is to take the sales and to take the advertising and to compare that to see if advertising actually helps with the sales. So scatterplot identify outliner. It allowed us to see if there is positive relationship, negative relationship, or no relationship at all. And the idea here is that the straight line upwards or downward, or there is no curve at all, indicate for us is it a strong or weak or unusual observation out of the data. So again, in this case, is a very positive. You see, as the number of hours spent in study, the better you have a final grade, a better score you get in your final grade, which means that you need to study. So this is a direct relationship with a positive. But negative relationship, again, can go to the other direction. The age of the car and the reliability of the car. Those two aspects has negative relationship or no relationship at all. Another form of analysis with regard to bivariate is the correlation coefficient, and it comes in many forms. It helps identify the relationship among points or value in terms of whether they change together or separately, and it usually refers to a small r, and the correlation coefficient of population is devoted as P or capital R. In other words, a sample refers to the observation of the item, draw from the population, and this is in contrast to the entire population where you examined each item of the population. So simple correlation coefficient, small r, is the value range from -1 to 1, and the correlation coefficient of -1 indicate a strong negative correlation, in compared to 1 that indicates strong positive correlation. And the correlation, when it equals 0, indicates that is a very weak or no linear correlation at all. So again, we have signals that we can indicate what is type of the relationship and how it plays out with regard to the data that we are trying to measure. So again, indication of indirect, direct, and those association or those measurements allowed us to have more coefficient understanding of the relationship between those two variables. And so how do we compute correlation coefficient R? Is very simple formula. However, when you think about that and when you need to do it manually, you probably will spend a lot of time doing so. And so today, in the second part of the class, I'm going to show you how we do that in R. But if in case that you want to know how to do that manually, example, age versus weight, and the sample of 6 children was selected, and about the age and the weight in kilograms was recorded, and this is the table. So we have basically two variables by a variable structure, and we have age, and we have the independent x as the weight that will probably we want to indicate there is a relationship between x and y. And this is where the things getting a little bit more complex. So the formula is the following. And so what we have, we summarize the total of age, weight, and we measure x multiplied by y, x square, y square, in order for us to do that. And so we end up with this idea of the r, small r, or the correlation is equal 0.759. So this indicates a strong direct correlation between age and weight. Okay, so now let's take another example, anxiety and test score. Again, we have the anxiety score, we have the test score, and we can measure that in order for us to indicate if there is a correlation. Indirect strong correlation is a negative, which means that we need to understand the context of the analysis. Another type of correlation coefficient is person sample, and it measures the strength of any linear relationship between two numerical values. So it draws a line of best fit through the data points of 2 points. So in this case, the value of -1 for a perfect negative linear relationship to a +1 a positive linear relationship. A value of 0 indicates no relationship between the two variables. The formula is a little bit different from what we experience. So we have a little bit more structure with regard to the equation. So again, the same procedure. We have the number of pairs of success scores, we have the products of the scores, and we have the sum in order for us to imply that, in order for us to implement that into it. Example using R in our textbook you can find in page 82, and where visitors of special collection versus visitor of archives room, and we have those two components, and we have a total in order for us to calculate. But this is example for the first value x is equal 1. So the calculation of the deviation or score, we can take 1 minus 4 equal minus 3, and the score value of 3 minus 4 is minus 1, and so on. So the person's R score, to achieve it, we have to calculate the whole line of calculation, the sum of the x and y, the square root of the product of the sum, and the x square versus and the sum of the y square. All those components are part of our equation that we must follow in order to us to succeed. So in this case, this is the result, and we always can visualize it in order for us to see that. So the x is the number of special collection room, the y is the visitors to the old archive room, and this is what we found. Computing person in R in comparison to any other platform such as Excel or SPSS, look how it is. So the idea of the command in R is called COR. And so what we do is we created two containers, X and Y, and we will say the third line, core test X and Y, which will give us in the end the person product moment correlation data in that value. So he will not only give you the score of the person calculation, but it will also give you the p-value and the df. I will talk about that later on, but I want you to keep in mind this is important information that we will start using when we are trying to do more advanced statistics. So, alternative hypothesis, true correlation is not equal to 0.95%, and an interval is equal to the following, and the sample estimate is this score. I will talk about those terms later on, but this is, for me, I want you to start thinking about that, just to have in your back mind that we are going to start talking about those terms. If you want, you can search it and see what it means in order for you to better understand. Next, the Sherman rank coefficient. It is another way for us to do correlation coefficient, and it's named after Charles Sherman. And it's often used the Greek letter rho, which is a pi square, and it is ability to measure statistical dependence between two variables, which is really important. So under the Sherman rank formula, there is no repeated data value, and a perfect Sherman correlation of 1 or minus 1 occurs where each of the value is a perfect non-node function of the order. So R rank is minus 1. So this is the formula. This is what we are doing in order for us to apply the Sherman rank correlation coefficient. And so we are talking about ordinal data, and it's already been rank form. So we are talking about interval or ratio data, and we convert it into ranking. So direct example, again from our textbook, public library users participate in competitive event that was organized by the town council. There's two events. One is bicycle race, and the second race is cooking a dish that's based on local farmers' vegetables. So the library selected 5 users and often read about bicycle and cook from their book collection. So the table shows the difference. So we have names, we have the cooking, number of cooking books that they read, and about the cycling books that they borrow, and we have D1, D and D2, and those are the numbers. So in this table, if we will apply the Sherman formula, it will give us the D square is equal 4 plus 1 plus 1 plus 1 equal 8. n is equal, the sample size equal 8, and the square root is 25. And so in this case, the R rank is 1. So in this case, this is what we'll do. Again, I'm going back to R because I want to show you why did I pick R. Why is it so important for you to understand that R can make your life easier? And we're all about making life easier. So in this case, X, Y, I have those values in that. I will say to R core test, and I will say X and Y, and the method will be Sherman, and he will give me the result that S is equal 8 and the p-value is equal 0.35. Alternative hypothesis true is not equal to 0, and the sample estimate is 0.6. I will talk about that later on, but I want you to have the mechanics in order for you to understand what it is. So today in this module, I covered the idea of two variable bivariate statistics that involve the analysis of X and Y, or any other two variables that are different from each other. So in this chapter, we review correlation analysis, and in particular, Pearson correlation coefficient and properties of Pearson's R correlation and causality, and we examine it through the eyes of R. We employed R to provide us example of the code that require us to run in the R. Now to the main subject of this class, the R program and how it matches to the statistical analysis that we learn. So R, again, is ability to store the data as our object. And I hope you remember what we covered about the R object last time. So in this case, we are declaring that A is an object, and in this case, A is equal 1. And in this case, I can add to it or calculate the object in this case. Good names versus bad names, again, I want you to be aware of it. What is the functions in programming language? We learned that in programming is a style of programming that emphasizes the execution of the expression rather than the execution of the commands. So in this case, we are talking about specific task in the sense that a function is a type of procedure or routine, and that in some programming language makes the distinction between a function which returns a value and a procedure which performs some operation that does not return a value, and this is part of the idea. In R, functions are the fundamental building blocks of R. So R comes with many functions, and let's take the example, and as you experience in the module number 2, you already use the function mean in order for you to calculate the mean of a container or an object. And in this case, it will provide you the idea of it. The second example in this slide is the functional, and this is a functional to any positive whole number n, and it will allow us to write some formula in order for us to calculate that, try to see if it makes sense. So here is the list of all the functions in R, and also can be used another list. I prefer to use, with my obsession with R, to use what is being posted on the R community, and the rproject.org is the community sources to that. So the data that you pass into the function is called a function argument, as I said that in the last time. So in this case, the mean or any other mean can be repeated inside a function that you yourself going to write. So you can write your own functions, and this is the beauty of it. It's not that me teaching you how to write a function, you can create your own function. Example, what is a sample? in statistics, a sample is a data collected from population, and we picked up a sample that represents the entire population. So in R, we have the ability to have a replacement. When you taking a sample and you are taking the sample and you take out what you selected, you can have a replacement. And so with a replacement or without a replacement, this is something that is really important because it will affect the end result of your calculation. So example, a container that I called C, its hold number from 1 to 6. I'll say to R, take a sample, and I will say from C, size of the sample 2, and I want it to be with a replacement. So he will come up with a replacement that will give it replacement every time I take this sample. So again, I gave you here example of potato snacks, which has 12, 13, 14, 15, so on potatoes, and all the values are equally likely to be part of the sample if we are using the sample as in the study. So again, the idea of a sample without a replacement and with a replacement, this is what you are going to to think about. And what is the difference is that where it is the two values are independent is what we are trying to achieve in order for us to have an objective idea of it. Go over that, see if it makes sense, see if it allows you to understand the idea of a sample. I will also add some reading about the sample. The function as a constructor. So the functions in R are a first-class object, which means that they can treat much like any other object. Importantly, function can be passed as an argument to other function. So the function can be nested, so you can define a function inside another function. So every function has three basic parts: a name, a body, and a set of arguments that it will make. To make your own function, you need to replicate those parts and store it in R. So the syntax of a function in R. Function have a name argument which potentially has a default values. The formal arguments are the argument included in the function definition. The formula functions return a list of all the arguments of the function. So not every function in R calls for a formal argument, but the function arguments can be missing or might have a default value, which might be a problem. I'm jumping ahead a little bit, but I want to make sure that you are going to get the right syntax when we are talking about all those components. I'm going to talk about normal distribution. And the idea here is that normal distribution is that if you have a sample and you have show the distribution, it shows that the distribution of all the components has equal normal distribution, and I will talk about that later on. Read chapters 7 and 8, and I'll give you also references in the notes. So in R, the command line is rnorm, which will give you generate a random number from a normal distribution. Dnorm is the probability density function. Pnorm is distribution function, and we have other forms. So in this case, we have a command, we have the purpose, the syntax, and how it will generate in order for us to ability to examine it or to provide some ideas. So normal distribution has two ideas: the mean and the standard deviation. Those are the location and the spread of the distribution in normal distribution. For example, the length of any textbook have normal distribution mean of 100 and a standard deviation of 16, the length of textbook produced before 2008, and have a normal with a mean of 280 with a standard deviation of 10. The family of normals can be standardized to normal with a mean and the variance of 1. This achieves the idea of the following formula. Z is equal to x minus the mean divided by S. So the code in R. We are talking about the code, and I just want to give you a taste of it. So R normal, we have 1 to 100, and we have 16. So if we will run it, it will give us 94.17. And if we will use the 2004 numbers, which is 1 and the mean is 280 and the standard deviation is equal 10, it will give us different score. So again, this is where we are going to see the normal distribution and how it display if we will display it this way. Another thing that we need to talk about R is the vector. It is a sequence of data elements on the same basic type. So the idea here is that we can call them numbers in this site or in this class. I use it in the example that I use in the website. I call it site, but in this class we call it vector. We are going to call it a number. So in this case, again, we can have the vector can have logical values such as false and true, and it can also contain a character string. If you went through C++ or Java or JavaScript class, you talked about character string, which is AA, BB, CC, or DA. So those are words that allowed us to have a string attached to it. When we are using logical vector as an index, we are trying to achieve the idea the position of the logical vector is true when it is returned. So again, a container, which is called X, has true, false, false, true. And if we will try to see where is the condition base, is it bigger or smaller than 0, we will get some indication where's the index lined up in that position. And again, if I will change it, I'll say bigger than 0. Again, this is what it is. So the idea of vector as an index, again, the type of indexing is usually dealing with name vector. Example, first equal 3, second equal 0, third is equal 9, and if we'll say name, it will give us the indicator. If we'll say second, what is the value of second, it will give us the true value of it, and so on. So again, the indexing is the way for us to convert from a word to a numerical value. Modify the vector is also possible, and it's part of the arrangement of how we do things. And so again, the idea is we can modify the second element, or we can modify the element less than 0, or change this rotation out of it. We can also delete vector out of it, and in doing so we can eliminate the container that we have. Another way for us to sort data is called matrix. It is a two-dimensional data structure in R. So matrix is very similar to vector, but additional contains dimension attributes. So in this case, the function dimension and what it represents. So in R, if we will say R, give me the matrix, he will show me that it contains data elements. He will give me the number of rows. He will give me the number of columns, and he will see if it will fit into the rows and be able to do that. So in this case, he will present the data as follows. So any element in the row and the columns of A can be accessed by the expression of M and N, and by doing that we are able to display it and to show what it is consists of. Another way for us to display the container of the data is a list. A list is a generic vector containing other objects. For example, the following variable x is a list containing copies of three vectors, n, s, and b, and numerical value of 3. So n is equal to 2, 3, and 5, c is equal a, bb, cc, de, dd, and ee, and b is true or false. And so in this case, we can list them together in order for us to do the calculation. We can also slice the list in order for us to see what it contains and to understand what it means. Integers is again another idea of a whole number, both positive or negative. So declare an integer variable in R, we use a function called asInteger. So you can confirm that x is an integer by applying the asInteger as a function. So x as an integer minus 3, and so it will display it as integer. A string is a collection of characters, and this is something that I hope everyone will be familiar. A string is a type of data integer that present in the form of text rather than numbers. So again, it compresses a set of characters that can also contain space and number. For example, A, which will be hello, and if we will say hello, B contain hello and 3, it will contain it. This is a string. This is the idea of a string. Characters is also a single element such as a letter of the alphabet or a number in order to convert object into characters in values in R. So we need to declare as a character, and we do that in the following format: as characters as a function. So in this case, x is equal as character 0.4, and that will convert it into a character. In this case, I can convert my name into a character. Factor is again the idea of a variable multiplied by itself. It is a R factor that takes a limited number of different values. Such values often refer to categorical variables. Categorical variables such as sex, such as grade in the class. So in the textbook, we define categorical value which represent type of data that can be divided into groups. And so to illustrate color of the color of the hair, it can be black, white, blonde, and gray. And so in this case, this is how we do that in order for us to do that. So the level is black, blonde, and gray, and white. And so the R factors provide us levels of black, blonde, gray, and white, and a level that is categorizes of the base it displayed. Logical is under logical variables, the variable that can hold true or false. So in R, the logical value makes a comparison between the variables and provide additional functionality by adding or subtracting. And for example, x1, y is 2, is x bigger than y, and it will say false. Again, I will post the issue of import data to R. There's different directions how to do that. I am accustomed to the terminal, not the RStudio. So in this case, I used to type all those letters in order for me to import. And so the idea here is how to do that. I still remind myself to do that because we always can do that. And nowadays, this is how we end up to do with R. So I will provide you more information. I will provide you more directions with regard that. I will provide you with RStudio PDF that will show you how to do that in RStudio. I hope it was enough for today. I hope you enjoy it. Until next time, have fun.